Hello everyone, welcome back to Algebra 2 class. Today we are going to continue talking about Unit 4, this two type of function, and today we are going to discover the very first type of function, exponential function. I believe many of you, when you see this function, you probably remember that's one type of function you already learned in Algebra 1. So today's lesson is more like a review. I hope this lesson will refresh your memory and recall something about regarding this function. So before we start the lesson, let's do a quick warm-up to review the lesson we introduced yesterday, rational exponents. So this question asks us to rewrite this expression without using fractional exponents, and then we are going to find the value. So let's get started. So this one, as we know, whenever I see the negative exponents, we can just easily to convert it to the positive one, which is 1 over, and we convert this to positive exponents, 2 over 3. And when we deal with 2 over 3 as exponent, we know which is, we can deal with as we deal with 1/3 first and then square. So, and that means 1/3 meaning cubic root of 8 and then get square. Of course, you can square of 8 and then find the cubic root. You will get the same answer. So the value, as we know, cubic root of 8, meaning we need to find a number. We need to find a number to the third power to get 8, which actually accidentally put the answer, which is actually 2. So it's going to be 2 to the second power, which is 1 over 4. And that's it. So this is just a quick review for yesterday's lesson about the rational exponents. So now let's talk about exponential function. So the reason we talk exponential function because it is a very, very useful function to model a lot of real life situations. I hope when you're watching this video, you are not eating lunch or those kind of thing, because this picture can be a little bit annoying when you actually eat. So the first one, as you know, a little bit, nasty. So the first one is actually the mold, one kind of, bacteria when we put the food without in the, for example, when you take out food from refrigerator, when you put outside a little bit longer time, this kind of bacteria can, very quickly cover all the food. So the way how mold increasing is actually can be modeled as exponential function. The other picture probably can definitely give you some warning message, because we already see very similar situation about the virus spreading. So right now we are facing a very serious pandemic, but this is actually not new. In human history, we already have faced many types of pandemic in the past. So this is actually one type of thing we can see, and the way the virus spreading is also can be modeled by exponential function. So speaking of modeling, this unit we are going to discuss more about how to use exponential function to model the real life situation. But let's just quickly imagine, for example, let's assume one mode can be increased, like can be doubled every 5 minutes. This is one. And then double every 5 units, that means, for example, this is mode, then doubled after 5 minutes we have 2. So each one after 5 units, I'm going to increasing another 2. And then another 2, another 2, another 2, another 2. So as you can see, after several times, this bacteria can increasing like crazily much. So this one, as you can see, we can be modeled by 2 to the x power. So beginning is like a 2 to the 0 power is 1, then 2 to the first power, then this is 4, this is 8, then 16. So it's actually doubled every 5 minutes. But of course, a real life situation can be even more crazier than this. But this is the idea to understand this is how exponential function looks like in a real life situation. So today we are going to discover two types of situation when we use exponential function. Let's discuss this two examples here. So the first one is when you sell a car, while the price of the car increase or decrease compared to its original price. So some of you even you do not have a car, or you don't deal with this kind of business, but in your common sense, think about this. Well, with when you use a second-hand car, it's going to be cheaper compared to the original one, or it's going to be more expensive. And when you sell a house, so generally speaking, the price of the house is going to be increasing or decreasing. So the first one, common in majority situation, the second-hand car is actually going to be cheaper, meaning the price actually decrease. So some student might like argue, wait, what about antique car? It can be like the value can be increasing. We are talking about like a common situation. We're not actually talking about car collection. So this is like common situation. Yes, the price of the car is actually going to decrease. And when we sell house, of course, we can argue, oh, depends on the location, depends on the economic situation, the price can be lower. But in general cases, this is, buying house is also one way to investment. So that's why when you sell it, most likely the price itself is going to be higher than original price. So it's going to be increasing. And both situation is not like, decreasing like a straight line. Like before is 20,000, then is like every year is decreasing $500. Not going to like this way. So more likely, the price decreasing or the price increasing also can be more accurately modeled by exponential function. So the increasing or decreasing is actually like a curve. And both of the scenario have a name for each kind, which are, when the price increasing, we call exponential growth. And when the price decreasing, we call exponential decay. And we do have a function to model each kind. So exponential function, here the first one, y is just a final value. A stands for initial value here. I don't know what happened to my pen, is not really working well. So initial value, and then exponential growth meaning starting with 1, and R meaning growth rate. Like so like the interest is 5% each year, or increasing 0.2% each year. This is a growth rate. And then T is over the time, like after 5 years, after 10 years, after 5 minutes, after 1 hour. So it depends on the situation you are talking about. This is a 1. And for decrease, for we call decay, exponential decay. So again, same thing, everything is actually same, but since it's decay, so it's 1 minus R over the time. Every single letter still represent exactly same meaning in the growth situation, but this one since it's a exponential decay, we just call this decay rate. So when you just look at these two graphs, or when you look at these two functions, it's more hard to really grasp this idea. So we are going to check some examples to have a judgment about which one we should use. So let's see the first scenario. When you deposit money into a saving account, you will receive 5% interest per year. How much money will you have in your saving account after 12 years? One thing I want to remind you is when we deal with this, of course, when you deal with bank account in the future, you will realize in America the interest is not so much. But when we put money, generally speaking, the bank will give you a certain amount of interest to increase the value of the money. So since we have the interest in there, we know it's going to be increasing the value. So this is going to be the model we are going to try. So now let's just put value for each part. Okay, so we know this is going to be the one we are going to use. So we know we just need to put an initial amount and then 1 plus. So here is actually the growth rate, which is 5% and over 12 years. So that's it. Some student might say, hey, we didn't know how much money we put at the beginning of the, when you open an account. You're right. So in this situation, we just need to determine is this gross and how do we put in. One thing I want to remind you is, sometimes we put a percentage here. It's very easy to make a mistake. So it's better we convert it to a decimal, which is this. So when we put in the calculator, you can say this is 1.05 to the 12th power. So that will be our final amount. Just depends on how much money you put in the account, right? So this scenario is going to be using this. The rest part is just only for the calculation, but the idea is this is going to be exponential growth. So now let's see the last example. If the population of a town is decreasing by 4% per year, and so we start with 12,500 residents, which of the following is its projected population in 10 years? So as you can see, the key word here is decreasing, so it's actually indicating we are going to use exponential decay. And also 4% is going to be our decay rate. So let's put in the value there. So we already know the initial population is this, and 1 minus. Again, this is 4%. So let's just, convert it to the decimal. Over 10 years. Now we are going to type everything in the calculator. So let's do the calculator quickly. So it's going to be 125,500 and parenthesis 1 minus 0.04 parenthesis. And when you put an exponential, you can put an exponent, you can put this little key here, x to the y power. So there is a little one here. So 12. And then, so the population, I'm going to just use a whole number here. And since it's an 8, I'm going to round it up. So it's going to be 7659. Okay, so this is actually after 12 years, the population. Oh, I think I made a mistake. It's actually 10 years. So let's rewrite it. Again, you don't need to break down. You can just type everything here. Okay. Oh, so it's actually more. I do apologize. So it's 8,310. So that's actually not exactly the accurate number, because in real life situation a lot of factors can control that, but use this one can predict this is about this number after 10 years. Also, one thing I just want to remind you is some student might say, how is that possible? Population of a place can be decreasing. Actually, this is actually a good question for you to think. How is that possible? Population is decreasing. It can be multiple values. Maybe economy in this situation is not so good, so people start moving out. A lot of things can happen, right? So this is just example for you to show growth or decay. I hope this video is helpful. Now you have a very, very good and refreshed memory about exponential function. And we can use to model a lot of real life situation, as you can see. Thank you so much for checking this video and study this topic with me. Take care everyone, see you soon.